Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Acids, Bases and Salts. In this chapter, we are talking about the different compounds and their nature. There are so many compounds around us in nature. Basically, they have got some characteristic nature. Some of them show property called an acidic property. Some of them are basic in nature, whereas yet another compounds are neutral, neither acidic nor basic. So, in this chapter, we are going to learn all these three types of compounds. So, we are dealing with one by one, like the name suggests, acids, bases and salts. Let's also go in this order. We know acids are actually sour in taste, whereas bases are bitter in taste. But we know that some acids are very corrosive. Not only acids, even the bases are highly corrosive. So in such cases, tasting and determining whether it is acid or base is not a good solution. For that, we are using certain other substances which can change their nature, characteristic nature, in presence of an acid or a base. Such substances which are indicating the nature of a substance, whether it is acidic or basic, are called acid-base indicators or simply indicators. Here we are dealing with two types of indicators. First type of indicators are the dyes, which can change their color in presence of acid or base. The second type of indicators are actually changing their characteristic smell in presence of acid or base. They are called olfactory indicators. Coming back to the first type, that is the dyes. The dye again can be natural or artificial or synthetic indicators. Some of the indicators that we use which are natural are, the major one is litmus paper. Litmus paper is usually used in the lab to find out whether something is acidic or a basic. Usually the litmus paper is extracted from a lichen. You know, lichen is a symbiotic association between an algae and a fungus. Lichen has, the extract of lichen has naturally purple color, but it is made red or blue for our use. Suppose if you take a blue litmus paper and you dip it in an acidic solution, you will see that it is turning red in color. That indicates acid nature of that substance. Whereas, if it is dipped in a base, that means that red litmus paper, if you dip in a basic solution, it will change the red litmus to blue. So this is a major indicator that we are using. Blue litmus changes into red in the acidic medium, whereas red litmus changes into blue in basic medium. Okay. Now another one we are using is turmeric. We are not using, actually we can observe it in our day-to-day life. If you have got a stain on your dress with some turmeric while eating, because we know all our culinary preparations we traditionally use haldi, that means turmeric. So while washing, we apply soap. The moment soap solution comes in contact with that stain, it turns reddish color. But if you wash with plenty of water, that reddish color will go away. That means turmeric is naturally yellow in color. It will remain yellow in acidic solution, but when we are applying soap, soap is a base. The basic nature will change the color of the turmeric to red. Another one is red cabbage. The red cabbage extract is red in color. So when it is in the acidic medium, it remains red. But when it becomes alkaline, it will turn green. Another one is hydrangea. Hydrangea is mainly an ornamental flower. There are different colors available, but here we are using the blue one. So the extract is blue in color. In acid it is blue, but in base what will it turn? Its color will change into pink. Apart from that, another flower called a geranium is also used as an indicator. Next two what we are telling are synthetic indicators. They are used in the lab. So phenolphthalein and methyl orange are the two indicators which are synthetic. Phenolphthalein is a colorless substance or a solution, and it remains colorless in acidic medium, whereas when it comes in contact with the base, it will turn pink. The same way methyl orange is orange reddish in color. In acid it remains red, whereas in base it will turn yellow in color. These are the indicators which are changing their color in presence of acidic or basic substances. Now the second group of indicators are olfactory indicators. They can change their smell. For example, onion, vanilla, clove and all. If you treat them with any of these acids, they don't lose their characteristic smell, because we know onion has a very characteristic odor of sulfur. Vanilla has its own pleasant smell, that's why we use it in many preparations. Then clove is also having a very natural fragrance of its own characteristic smell. If it is retaining that smell, it's not losing the smell in spite of putting in the compound, then it is acidic in nature. But if it loses its characteristic smell, onion is no more smelling like an onion or sulfur smell, or clove oil is losing its smell, or vanilla is losing its smell, then that compound will be basic in nature. All these details we need to know about indicators. Now we will move on to study in detail acids. We have to learn chemical properties of acids, but before we go into chemical properties, let us discuss the physical properties of acids. First thing we saw, acids are sour in taste. Acids turn blue litmus to red color. Solution of acids can conduct electricity. So these are the physical properties. Now coming to chemical properties. So before we go into the examples with the equations, first let us by heart this so that it will be there in your mind, so you know. Then after that you can apply any acid or metal randomly so that you can find the answer. The same way in the question paper, if one acid is given, one base metal is given, you know how to go about it, right? So first you by heart this 4 reactions we have to study in terms of acids. Acid plus metal gives salt plus hydrogen. So when an acid reacts with a metal, what is evolved out? Hydrogen gas is evolved out. Acid plus metal carbonate will give salt plus carbon dioxide plus water. The same way metal bicarbonate also reacts with acid to form salt plus carbon dioxide plus water. So the products are same, that's why I wrote it together. Carbonate has CO3, so from that CO2 will be evolved out. Now acid when reacts with a base, if an acid and base both are opposite in nature, if they combine together, what do we get? Salt and water. Such a reaction is called a neutralization reaction. Acid plus metal oxide, we get again salt and water. So look at these two products, salt and water. Here also acid is common, only base is changed into metal oxide, but we are getting the same product. So we can say that these two are similar in their chemical properties, right? So we can say that metal oxides are basic in nature. So instead of a base, we can take a metal oxide, still you will get a neutralization reaction. So that indicates that metal oxides are basic in nature. So these are the reactions of acids, but at the same time, I am considering these two together now. Non-metal oxide, if you take, oxide of a non-metal, if it is reacting with a base, again you are getting salt and water. So in this case, base is here, salt and water here, so what is changing? Instead of acid, we replace non-metal oxide, then we are getting the same result, means what? Non-metal oxides are acidic in nature. So this also you can remember, metal oxides are basic in nature because they react with acid to form salt and water. The same way non-metal oxides are acidic in nature because they react with the base to form salt and water. Now we have to see each reaction with their examples. First reaction is acid plus metal gives salt plus hydrogen. So a typical example of this reaction in the previous video, if you remember the previous chapter, we took some zinc granules. Zinc granules were added to sulfuric acid. So zinc is a metal and sulfuric acid. What did we get? We saw that there was a gas coming out and we tested that gas as hydrogen gas. So how did we test the presence of that gas? So usually we have to bring, if you collect that gas in a test tube, we can bring a matchstick near it. If it burns with a pop sound, then it is hydrogen. Otherwise in this experiment we saw, we can pass the gas collected through a tube to a soap solution. Then the soap solution will start producing bubbles, fill this particular gas. If you bring a flame near it, it will break with a pop sound. So whenever you hear pop sound, that is hydrogen gas. So let's see the equation of this. So acid we can take sulfuric acid H2SO4. Then metal we are taking zinc. This is in aqueous, this is the solid phase. So what happens? This sulfate and the zinc will react to form ZnSO4, which is zinc sulfate, and what will we get? Hydrogen we get. So here we can see hydrogen is displaced from its solution by a reactive metal called zinc. We learned reactivity series displacement reaction in the previous lesson. So there we saw hydrogen is coming below the zinc. So definitely zinc can displace hydrogen because it's more reactive. There are other metals which can displace hydrogen from its solution, like acid. We learned so many metals above it: potassium, sodium, calcium, magnesium, aluminum, all these. So whichever whichever metals can displace hydrogen from its solution or acid, they are called active metals because they are electropositive in nature, because they have a tendency to lose electron and become positive in nature during a chemical reaction. We can write other examples of this. Or otherwise, the same reaction we can write with another acid, hydrochloric acid, HCl, plus again zinc. What will you get? ZnCl2 plus hydrogen will be liberated out. So 2HCl plus Zn gives Zn chloride, zinc chloride is the salt, plus hydrogen gases evolved out. We will see another metal, hydrochloric acid plus sodium. Sodium is also a very reactive metal. What will you get? This chlorine and the sodium will react to form a salt called sodium chloride, and what is left out? Hydrogen will be 2HCl plus 2Na gives 2NaCl plus H2. One more example we will see. Magnesium then reacts with the sulfuric acid. So what will you get? Magnesium sulfate, you will get MgSO4 plus hydrogen gases evolved out. So here everywhere what these we are getting are the salt solution, and where what we are getting the gas is hydrogen gas. One more thing we have to remember here is there are many substances which we use in our daily life which are acidic in nature. For example, curd, lemon juice, orange juice or vinegar. All these substances we should avoid taking in metal vessels like copper, brass, etc. The reason is the metal will react with the acid contained in it, and as a result some toxic substances may form that can be very harmful for our health. Next reaction of acid is acid plus metal carbonate gives salt plus carbon dioxide plus water. So we will try one. Acid we can take a hydrochloric acid, plus metal carbonate we can say sodium carbonate. So here acid is aqueous, sodium carbonate is solid. So what do we get? The sodium and the chlorine will react to form sodium chloride, which is the salt. Then what is left out? From this carbon dioxide is coming out. Then that oxygen left out is reacting with the hydrogen to form water also. So here sodium chloride is aqueous, this is gas, this is liquid. So coming to the balancing, sodium 2, so 2, carbon 1, oxygen 3, so 2 plus 1, 3, then hydrogen 2, chlorine 2. So 2HCl plus Na2CO3 gives 2 NaCl plus CO2 plus H2. Reaction if it is with a metal hydrogen carbonate or metal bicarbonate we say, means one hydrogen is also there, so it will become HCl plus NaHCO3. H comes means bicarbonate or hydrogen carbonate we say. So what will you get? The result is going to be the same. So sodium chloride plus what is left? Carbon dioxide and water left. So this is already balanced. We know HCl is aqueous, sodium bicarbonate is solid, this is aqueous, this is gas, and this is liquid. Okay, so these two are examples of metals carbonate or metal bicarbonate reacting with an acid. And you can try with other metal carbonates or you can try with other acids also, the result will be the same. Now we should see how to test for the presence of carbon dioxide, because already we saw how to test for the presence of hydrogen. Carbon dioxide is coming out as a brisk effervescence, means thick fumes. So here the carbon dioxide can be tested by passing it through lime water. So lime water we know it is calcium hydroxide or slaked lime is otherwise called a lime water. When it reacts with this carbon dioxide, when we are passing this carbon dioxide through this lime water solution, what will we get? Calcium carbonate will be forming, which is a solid precipitate, insoluble substance. Then when what will be removed out? Water also will be forming. Okay, so in this reaction, due to the presence of an insoluble calcium carbonate forming, this solution will turn white in appearance. So we say carbon dioxide can turn lime water milky. So that is the confirmatory test for carbon dioxide. So here this reaction happens on the whitewashing part also we learned. After whitewashing, the calcium hydroxide reacts with carbon dioxide to form a white coating on the walls, the same reaction. But here, so we know carbon dioxide is used to, carbon dioxide can turn lime water milky, so it is a confirmatory test. But if you pass excess of carbon dioxide through this calcium carbonate, it's already in water, so we write water also, we will get calcium hydrogen carbonate or calcium bicarbonate will form, but it is soluble. This was insoluble solid, this is gas, this is liquid. But when we passed it through the aqueous solution, it became aqueous, means it is soluble. So once it starts dissolving, we will not see that white color. So while passing carbon dioxide through lime water, it turns milky first, but on passing excess of carbon dioxide, it will turn colorless again due to the formation of soluble calcium bicarbonate. Next reaction is a very important reaction which is called neutralization reaction. Neutralization reaction means acids and bases react with each other to form salt and water. Here we have taken hydrochloric acid, which is a strong acid, and sodium hydroxide, which is a strong base. So these two react to form a salt sodium chloride and water is also produced. So this reaction is a neutralization reaction. Now we will see acid if reacts with a metal oxide, what happens? Salt and water will form again. So from this we know bases are like metal oxides, or we can say metal oxides are basic in nature because it reacts with acid to give salt and water. This is similar to the reaction of base. So hydrochloric acid is taken as an acid. The metal oxide taken here is copper 2 oxide, which is black in color, but it turns into blue-green solution, that is copper chloride, and water is also produced. So these are the main chemical properties of acid. So acid reacts with the metal to form salt and hydrogen. Acid reacts with the metal carbonates or metal hydrogen carbonate to form salt, carbon dioxide and water. Acids react with the bases to form salt and water, which is called neutralization reaction. And finally, acids reacts with metal oxide to form again salt and water. So metal oxides are basic in nature. So these are the chemical properties. So rest of the chapter we will learn in the coming videos. If you understand my lessons, please give me a like. Also give your valuable suggestions in the comment box. I would be really appreciative of that. And thank you for watching. Please subscribe to my channel, Biology My Passion.